Okay, so we're back for day 2 of these 1.1 notes on like terms. Again, if you are following along using paper and you are not using this specific note sheet, no big deal. You're going to be writing the examples just like everyone else is. So yesterday we talked about what an equivalent expression is, what a coefficient is, what a term is, and what like terms are. So today what we're going to be talking about is what it means to simplify some expressions to make equivalent expressions. So let's go ahead and just get started and write down our first example. So example 1, I would say just a simple direction of simplify. And what I'm asking you to simplify is this expression. So I want you to write this down. 2x plus 6x minus 4y. So if we are going to be simplifying, we need to make sure that we are still writing equivalent expressions. I can't make something more simple in math if I'm going to change what it is in its essence. Okay, and what we can do is we can make it look different as long as it is still equal. So that's our goal. We're going to make this into an equivalent expression, but it's just going to be a lot more simple. So the first thing I want to do is, my apologies if you can hear that, it's the first Wednesday of the month, so the tornado sirens are going off. So the first thing I want to do is I want to identify the terms in my expression. So just like I said yesterday, we're going to read from left to right. I know that every time I see a plus or a minus sign, that starts a new term. So I've got a 2x, I've got a positive 6x, and I've got a minus 4y. Notice how I'm including the signs in front, the plus and the minus signs. So I'm allowed to do what's called combining like terms. So I'm going to identify the things that are like terms. And remember, that's a term with the same variable. So I see a 2x and I see a 6x. So what this is really saying is there's 2 x's here, and then there's 1, 2, 3, 4, 5, 6 x's here. So in total, I have 1, 2, 3, 4, 5, 6, 7, 8, right? Because 2 plus 6 is 8x. Now, similar to this example, this sad little 4y down here has no one to combine with, and that's okay. So then this is just going to drop right down and be at the end of our expression. You can see that it's a lot more simple because we started with 3 terms, 1, 2, 3. So let's fill that in. We had 3 terms. And now our simplified expression, 8x minus 4y, has only 2 terms. Right? So it's a lot more easy to look at. I can see how many x's I have. I can see how many y's I have. Let's look at another example. And I want you to remember that at any point in time, if I'm going too fast, you can always push pause, rewind, all that good stuff. So again, we're going to simplify. And the expression that we are going to simplify this time is 7a minus 2 plus 8 plus 10a. 7a minus 2 plus 8 plus 10a. So, first things first, let's identify the terms in this expression. I'm going to read from left to right. I already see 1, 2, 3 plus or minus signs, right? So I can kind of picture those as like the walls separating my terms. So I'm going to have 1, 2, 3, 4 terms. Okay, reading from left to right, the 7 is the coefficient for the a. I include the minus sign that's attached to the 2. I include the plus sign that's attached to the 8. And then I include the 10a with that plus sign, because English reads from left to right, so does mathematics. So now when I'm looking at this, I am allowed to simplify by combining like terms. So what are the like terms that we have? Well, I see an A here and another A here. So I must be allowed to combine these two. And you might find it a little bit easier to rewrite it down below. So 7A plus 10A. And once I rewrite it, it should be pretty clear, right? I've got 7 A's plus 10 A's. That looks like there must be a total of 17 total A's. Now, the next part here is going to be really important that you write very carefully. So both of these are numbers that don't have a letter attached to them. And that means they're like terms, right? Because if you think about the definition of like terms, it's terms with the same variable. Well, this has no variable, just like this has no variable. And when you think about it, this is like back to the good old days of math class before there were letters, right? I've got a 2 and an 8. Okay, so what's important though is that this 2 is a negative 2. This 8 is a positive 8. Yes, you can use a calculator if you would like to. I think of this as like 2 weights pulling me down, right? And this would be 8 balloons pulling me up. Okay, so times 2. So I'm going to have a total of positive 6. It's okay if you want to use a calculator for that. Now, let's identify. In our original expression, we said we had 4 terms. In our simplified expression, we took those 2 A terms, 7A and 10A, and combined them to get 17A. So I'm going to write that, 17A. And then we took the 2 things that didn't have any variables attached. They're called constants, negative 2 plus 8, and we got a 6. Okay, but just like how the original expression is separated by plus and minus signs, if this is the second term and it's positive, I need to put a plus sign to show that it's separate from that 17A. Last expression. So again, we are going to simplify. And I want you to write down m minus 8m. Looks creepy simple, right? But there's a couple tricks on this one, so I want to make sure we're looking at it. So first things first, let's identify our terms, right? So I can see there's only one minus sign here. So I'm kind of envisioning this being like the wall that separates my terms, and that means I've got one term on the left, one term on the right. So there's going to be 2 terms in this original expression. Now, when I read this from left to right, this is my first term, and again, this is my second term. Now, what gets a little bit complicated about this one is when we think about the coefficients. Now it's hopefully clear to you why it's important what a coefficient is, right? Because a coefficient would be that number in front of a letter, and it tells us how many of that variable we have. Well, when I look at this first term, there is no number sitting in front of it. And a lot of kids look at this and they think, well, it's 0, right? If there's nothing, it's 0. But I have an m, right? There's an m sitting there. And I want you to think, how many m's am I looking at right here? Not 0. It looks like there's 1 m. And I know that must be a little bit annoying, but a long, long time ago, math people decided that if there's only 1 of something, you don't need to write the coefficient. That said, if you want to write the coefficient of 1, you absolutely can. I call it the secret hiding 1. So I do have 2 like terms here, right? I've got a 1m and I've got a negative 8m. So I can combine like terms. But the other weird thing about this is I have positive 1 and I'm taking away 8 m's. So this expression is going to end in a negative amount of variables, negative 7m. And that's okay. That happens sometimes. So I started with an expression that had two terms, and now my simplified expression is just one term, negative 7m. So before you go on to the practice for today, I would encourage you to complete these two reflection questions. As always, this video is here for you to rewind, rewatch, pause, and reach out to Miss Powers if you are feeling stuck or confused.